Okay, welcome back. It is day 151 of coding every day. So my demo for computer architecture is tomorrow, the final demo. Um, I it's been every demo that I'm like, yeah, I'll be able to like finish this like day before, and then I meet with my partner, we do some work, and it's like we go over like what we need left, and it's like, oh wow, there's still like a lot that I want done before that demo. So I hope I'm not staying up too late tonight. But the things that I need to show tomorrow is a working um, matrix multiplication that utilizes the entire cache multiple times. Um, so we can see eviction in the cache. And then we want to be able to show with and without pipeline to show how much with and without cache so we can see how much the cache like means. Um, yeah. So gonna do that. And then we need a sorting algorithm. So the idea, I think, what it's gonna be is, so um last time I had it where, what am I trying to say here? Oh, that when I took a branch, I wasn't squashing instructions. I was just removing the instructions before it at execute, which is not right at all. What's supposed to happen is when you get to execute, right? And you know that you're going to be taking the branch, you want to set every single register to have a status of squashed. So now every single register that every single stage that has something in it is marked as squashed. And so until that operation gets to write back and writes the new program counter, right? Because I was writing, because it's a simulation, not a real thing. I technically I can write, to the program counter in any stage, but that's not how that works. It's supposed to be in write back is when you do your write back, to whatever registers. And so the program counter is a register, right? Um, so now it's when you get to write back and it, writes back, then everything goes to false. It's not squashed instructions. But then you also have to flush, the pipeline of those squashed instructions even when it leaves. So that was the whole thing. But I need to show that. I think I'm going to show like that during the sorting thing, and also some more data hazard stuff of just forwarding instructions. So, those had to be fixed, and those are good now. Um, and so now there's the big thing is just the matrix multiplication. I'm thinking it's going to have to be a 5 by 5 matrix. And so the thing right now is, in my instruction set, for branching, I only have a branch if equal and branch if less than. Um, and that's not enough because now you could do this on conditionals, but the problem is I'm having a 16-bit architecture, right? So 4 bits for the opcode, 4 bits for the first comparison register, 4 bits for the second comparison register. So that leaves me with 4 bits for the immediate on where to branch. Now, if I'm doing a 5 by 5 matrix multiplication, I have to take the values from one matrix, the values from another matrix, compute those, take that, put it into DRAM, right? And so all of that takes, a 4 bits can only do 15 moves, right? It's going to take more than 15 lines to do all of that, right? So I'm going to have to add an explicit jump operation, which we had at one point, but my professor said you could do like an or between the program counter and something else. I can't figure it out, so I'm just going to add an explicit jump. Um, but yeah, I'll show you where I'm at now. That'll kind of be my um, I've been coding literally all day. It's been hours and hours and hours. So I'm just gonna show you where we're at. Uh, do a run all. My partner made this nice little virtual runs the API interface and whatever in the background. So um, actually, first I'll show you just kind of some of the updates of pipeline. So first off, we now have um, a delay on fetch from DRAM. So DRAM's defaulted to 4 cycles right now. So we step through. That is finished. So now we can go forward. Also, we have it so that um, if we go to cache, you can see these values in cache. So when I go to that first instruction, it's not in cache, right? So it's a miss. It's a read miss. So we end up going to cache, and after our 4 cycle delay, we bring a block of 4 lines into cache. So these are the 4 lines, right? You can see, because these are 3 adds, right? They're all 0 opcodes, so they're a low decimal number or whatever, and then the high is because the opcode changes. But that brings that in there, so you can see the actual delay just goes down to 1 because it's a cache fetch. So that's everything that was fetched, and now we'll go back to a 4. Um, Also, the cool thing is when we get to memory right back, it um, it halts the fetch and then does memory, which might not be correct, but it does take precedence. Um, Then we fetch that, do that. Um, you can see we go back to here. Once that's done, it'll be, you know, that got put into cache. So you can just kind of see, you know, register 0 equals 3. Register is 3. Store word at address 3 3. Right? So memory at 3. This is gonna be set to 3, right? That's set to 3. And whatever. Okay. All right, there we go. So that's all set up and nice. Reset isn't working, I don't think. Because if I go here and then I do my 4 by 4 matrix and I do a step. Oh wow, no, it did work. Okay. Did that work? No, it did work. Um, yeah. Okay, but you can see this is a 4 by 4 matrix multiplication that I like asked ChatGPT for. 300 lines of code because I don't have branching set up. So this is how I have to do it. So if we look in memory, well, actually, I say if we look in memory, it's going to take a while to look into memory. I also need to do a jump. I need to add down there like a jump by X amount of an program counter, or do X amount of cycles so that we can get through this faster, so I can like show what's happening. But are we there yet? Okay, so this is the first matrix. 0 through 7 is the first matrix. So top row is 1 2 3, and then we have 4 3 2, whatever. So that's the first matrix is loaded into there. Um, and then the second matrix is from 8 to 17. Okay. Now we're gonna see this is the result of C. And that should be that. What is even happening here now? Oh, this is a 4 by 4 matrix. Oh. I thought this was the 3 by 3. So the 4 by 4 is here to here's the first matrix. Yeah. I'm like, what? This should already be over. Okay. But you can kind of see just like how, um, as we step through, right, you can see each one of these memory slots changing to the correct value. So this one just got set to its correct value. Whatever, right? Takes a lot of cycles. And eventually, this DRAM should be 100 cycles, is what my professor wants. So that will take thousands of cycles to get through a 4 by 4. Um, and actually, maybe we just do a 4 by 4 because, I mean, look at the cache, right? Yeah, wait, actually, a 4 by 4 is perfectly fine, right? I mean, we're pulling in 8765, which should be, I have the result um, here. So this should be the resulting matrix is 19 is like the first value, whatever. Um, but what we're actually, oh, I wish I could see what the original matrix was. Actually, one second, let me pull that up. All right, I'm back. I got so the original one is 124, 123, whatever. These are the lines. So I'm guessing 8765, 8765, right? This is just the line of that or whatever. So this is actually really nice. Um, so actually, technically, worst case scenario, right? Worst case scenario. This does fill up the cache, and we do see eviction with a 16 line cache, 4 words per line. Okay. So we do see eviction when doing this. We can see that just got pulled in. Yeah. Yeah, this is just great. This is actually just great. Um, and so the resulting matrice, it starts at line 32 right here and goes to 47. So if I just hit like run instructions now, oh, did it not like that? Will 32 update? Okay, I think we messed something. Okay, hitting run instructions halfway through does not help. Okay. But we can see that like that's actually really I can't believe I never like actually checked that. Because okay, the reason I never checked that and manually clicked 400 times um is because right now my run instructions, like when I click that button, it's not running until like a dynamic end, right? So like this is probably around what 800 cycles. Um Ideally, right, when the pipeline is done, we've gone through every single instruction and the pipeline is flushed, it should automatically detect that. I can't figure that out right now. I don't know why it doesn't work, but so I just have like a hard set cap of 2000. So when I run it, right, the cache just like zeroes out. Um, which I mean, I'm guessing it's just like because I don't even know why that'd be, to be honest, because I don't think cache should only be on reads that it's updating. So I don't I don't know because I mean if we go to yeah I'll launch it one more time. If we go to let me close these as well. CD scripts Windows um, run all. Um, I'm pretty sure if I load this in and just do run, the cache does not look like that at all. Like if I do this and then run and then we go to memory, right? These are all the values that we want, okay? But if I go to cache, it's all zeroed out. It's literally just all zeroed out, which I don't really get. Because it shouldn't be, you know, maybe it has to do with something on like my run instructions is not working because I don't see how this would be zeroing out the cache. Um, anyways, so that's all I have for now. I'm gonna go back to painstakingly working on this. Hopefully, I can get some sleep tonight, um, and then have a good final demo. Um, I feel like there's something I'm gonna, mess up, and he's gonna kind of grill me for since it's the final one. Um, I feel like it's gonna be have to do something with I feel like it's going. I don't know. When I was watching the last demos, it really did not look like people had delay on fetch. I'll be honest, but he like told me that, so I feel like I might have implemented it wrong. I also feel like maybe my squashed instruction stuff just isn't. I don't think the fetch I did wrong. I think it's supposed to be though. Like I don't know. I don't know. We'll see. Um. Yeah. I don't know. I think it might be fine. Whatever. Okay. I'm gonna go work on this, and I will see you tomorrow, and let you know how it went. And then it's full. I just have to fully work on computer system principles and linear algebra. So, okay, I will see you tomorrow for day 151, and I'll tell you how it went. So, goodbye. Take care. Bye.